Lesson 1-7 was over 2 more properties of integer exponents. So in the last lesson we learned about the product of powers property, the power of products property, the power of powers property, and the quotient of powers property. And today we're going to learn about the zero exponent property and the negative exponent property. So the objective for today is to simplify and evaluate expressions with zero and negative exponents. So for example 1, we're going to talk about exponents that are 0. So Marcella is playing a card matching game with some classmates. 4 matches have been made. It is Marcella's turn and she chooses 3 to the 0 power. What card would complete her match? Okay, so we're trying to figure out what this would be simplified. So the first option, just like in the last lesson, they show you kind of the longer way to do the problem, and then they show you the actual property and how it works. So for option A, we're going to organize the information into a table and look for a pattern. So when you were doing 3 to the 4th power, we're doing 3 times 3 times 3 times 3. And 3 times 3 is 9, times 3 is 27, times another 3 is 81. 3 cubed, that's going to be 3 times 3 times 3. 3 times 3 is 9, times another 3 is 27. Then we have 3 squared, which is just 3 times 3, which we know is 9. 3 to the 1st power is just 3. And now we're going to look for a pattern. So as we look at the relationship here, what you should notice is that we're getting 1 less 3. And so essentially what we're doing here is we're dividing out one of our 3's. So 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. So if I continue that pattern of divide by 3, and I do it to my 3 to the 1st power, 3 divided by 3 is simply 1. This 1 is the answer for any integer raised to the 0 power. Option B is to use what we learned last time, which is the quotient of powers property. So I can rewrite 3 to the 0 power as 3 squared divided by 3 squared, because 3 to the 2 minus 2 power is the same as 3 to the 0 power. When you write this out in expanded form, I can write it as 3 times 3 over 3 times 3. Since there's an even amount on both top and bottom, they're actually going to cancel each other out, leaving us with 1 over 1, or just 1. So the 0 exponent property states that any number to the 0 power is just 1. So for example, if I have 1 million raised to the 0 power, that's still going to equal 1. Any number to the 0 power is 1. Example 2 is when you have the negative exponent property. So here we have simplify the expression 4 cubed divided by 4 to the 5th. So we're going to do what we learned last week, or not last week, 2 days ago when we talked about dividing powers. We're going to set it up as a fraction. So 4 cubed divided by 4 to the 5th power. Okay, I'm going to start by expanding it out so we can see what this would look like when all of our numbers are being multiplied together. So I have 4 times 4 times 4 all over 4 times 4 times 4 times 4 times 4. Notice that we have more 4's on the bottom than we do on the top. When I go to cancel these, I'm going to end up with nothing on the top, just 1 over, and then on the bottom 4 squared. Okay, and 1 over 4 squared, we can simplify that since we know what 4 squared is, as 1 over 16. Okay, now using the quotient property, what we can do is instead of expanding it all out, we can use what we know and subtract our exponents instead. So I would do 4 to the 3 minus 5 power, which is 4 to the negative 2 power. And 4 to the negative 2 power is going to be the same as 1 over 4 squared, which is 1 over 16. So the negative exponent property states that when a number is raised to a negative power, it's equal to 1 over that exponent raised to the positive power. So I changed this negative 2 to a positive 2 and put it under 1. And that's how you would rewrite it, as using positive exponents. Now sometimes you're going to have a negative exponent in the bottom of your number here. So we have a fraction and now the negative's in the bottom. It's going to work the opposite of what we just did. So here I can rewrite this, since I know that this 1 over 7 to the negative 2, I can rewrite as 1 over 7 to the positive 2, because we learned that this is the same as this. And 1 divided by 1 over 7 squared. If you remember back to when we divided fractions, we rewrote them as 1 times, we changed it to multiplication, and then we flipped our second fraction, so 7 squared over 1. We can rewrite this as a multiplication problem, and you end up with 7 squared for that multiplication problem, and 7 squared is just 49. Okay, so essentially, whenever you have a negative exponent in the denominator of a fraction, you're going to make it positive, and then you're going to move it to the top of the fraction, the numerator, which essentially is just 7 squared. And I just noticed that that's not a square, that's a cube. So all of these need to be 3's. Should have put my glasses on. Okay, so 7 cubed is our answer for this one. So just to kind of give you another example of this off to the side here, I'll give you 2 negative ones. So if I have 2 to the negative 3 power, and I have 1 over 2 to the negative 3 power, this one is going to equal 1 over 2 cubed. This one is just going to equal 2 cubed. So this gets moved to the denominator. You can think about this being over 1. It's almost like they flip spots, and this becomes positive. Same thing here. These switch spots. My denominator now becomes my numerator, and the exponent becomes positive. Okay, so we're going to get some more practice with these, and those are all of the integer exponent properties.